Thank you very much, Dean Rodriguez, and I always call him as Paco if it's known him for a quarter of a century. And thank you very much, Dr. Bros, for invitation and hosting this event. I'm absolutely honored to be receiving visiting lectureship here in honor of Cesar Pelli. And at Harvard, where I teach, and especially as senior faculty, they really don't want us to go anywhere and teach. And so I had to get the permission of a dean in order to do this. But at the GSD, everyone loves Paco. And everybody says, if Paco wants Toshiko, we have to ship her out to his school. So, and that's one of the reasons I'm here. He's loved by many people. And I fondly remember visiting him in Puerto Rico, where he was dean, and really amazing amount of energy to promote Caribbean architecture, which really didn't have any identity or home. And I saw him hire many young architects to be teachers there. There's an amazing active scene. I was very impressed with it. And I was just talking to everybody, like when he was ACSA president, he was very instrumental in pushing architecture as STEM education, which many of your international students, you have to thank Paco for getting longer visa, and then also to be able to receive more grants in the science and engineering field. So it's actually a huge advance in terms of profession that Paco had contributed. So I'm very, very sure that I know you have arrived recently in this school, that the future of this school is bright, and I'm actually very happy to be contributing with his effort in this particular fashion. But also in honor of Cesar Pelli, as Paco mentioned, he is a quintessential New York architect, incredibly stylish, and then incredibly elegant, and beautiful lectures he always gave, and amazing buildings he builds, and his son and partners still carry on his legacy. So I've known him, I've gone to his lectures at Architectural League, except they served Italian food instead of Argentinian food. So it was like a not very appropriate. But and I also taught at Yale, where he was a dean, and he really transformed Yale to School of Contemporary Practice and Contemporary Teaching. And I think one of the things I share with them, which is like, I'm a professional architect, I have an office, and Cesar Pelli also had like much bigger office than I, and completely committed to practice and also pedagogy of a future generations. And that's actually some things I think we share in common, and it's a very important aspects of our profession that my mentor, John Haydock, who was also given the first teaching job by Paul Rudolph at Yale. So Yale has a very interesting trajectory of identifying very talented architects that has future implications, that teaching is a birthright of architects, don't give up. And Cesar Pelli did that all the way through, and that's actually something I think I share in common with them, to balance both profession and teaching. So thank you, this is an honor. And I will start to share my screen. And my, can you see it? It's okay. And my lecture is titled Observations, as Paco mentioned. It's the title of my book. As architects, we observe in all directions, looking back, looking forward, and sometimes jumping far ahead to anticipate new conditions and emerging trends. The practice of observation provides a means for creating narratives, stories with many plots and elements that can be used to explore prospective ideas and presage the future. So in terms of framing a future, theme of this series, I'd like to really present this idea of observation, which actually needs to be coupled with capacity for imagination as an important way of practicing architecture. So I will just show a few projects. And first one is actually in my neighborhood. I have an office in Soho, and this is on Mott Street in Little Italy, Nolita area. And there was a very small spot. It's only 20 feet wide by little less than 60 feet deep. And the client came to ask us to build a new building. And it's a bit of a historic district in which we are required to conform to existing code. And as you can see, it's mostly masonry buildings. And there's also a St. Patrick Church in there. So as an architect and also as a New Yorker, you walk up and down the street and you realize that you actually never have this view in a city. Streets are too narrow and you never get a frontal view of a city, except that you are always going up and down and you are viewing a building askew. So this actually observation in terms of your habit. So in a way, I wanted to propose a facade that you can actually view up and down the street from side, so that this particular perception of how the building looks might actually generate interest. So it's not flat. And so we came up with the idea of a twisted masonry facade, because this neighborhood had to be masonry. But the footprint of these buildings are very, very small. It's about 1,000 square foot footprint. And then it has a courtyard in the back. And this is actually for the retail commercial purpose and offices. And it's 7 stories. This was a ground up building like this. And in order for us to really do it, we had to do nearly as of right. And we only had a space about 18 inches to have this twisting of a stone work out. And we had to be very carefully calibrated as to how the perception of walking up and down the street as a casual way of life, and then how to actually craft this. And in our office, we work very precisely in terms of materiality. We actually do every single part of a stone as it rotates up the building. And so that, and then actually the front and the back are sandwiched by the structural elements as a cupping here. And then we actually have this catalog of different sizes and parts, and work very closely with manufacturer in Italy. And it's actually very near Pisa, and used the fair trade black granite in order to come up with this particular idea of a facade. And these are some of the drawings which shows different moments. But in a way, in order for us to achieve the effect we want, we had to really basically draw everything up, and then everyone fabricated from it. In a sense, we have to make kind of shop drawings out of it. So this actually shows the development of some of the drawings from bottom up. And then this shows a section through it, so that it comes from a more deeper section, but it rotates and becomes very flat as it travels to the top. On the back of a building where it faces west, it actually needed some of the shading. So we used the same twisting idea, but we used a 3/8 of an inch thick blade of a steel, 5 inches, and it twists at angle change of rate of 3.75 degrees throughout. It actually creates a shading device, as well as idea of a screen effect, which is very similar, but in terms of change of scale from facade scale to much more different scale of a back. So these are some of the drawings that we collaborated closely with fabricators. I'm just showing it because our office is not very big, but we actually get very carefully working with craftspeople all the way through to the building to make some full-size mock-ups, and then make drawings to test things out. And we've gone to the site to work with masons. And in this fabrication process is very interesting because they combined digital fabrication and also a mechanical fabrication. And also they finished everything by hand and checked it. So 3 parts of crafts were combined. This is one of a very ancient part of Italy, where very close to where Michelangelo used to get the stones from this site. So this is actually using with much more traditional ideas. So this is a building in context of it. And that's what it will look like when it's actually going up. So one of a kind of a tricks, but it's actually by code, by zoning code, what we did is that the proportion of masonry has to be equal to existing buildings. But as you can see, existing building has punctured windows. But instead of making punctured window facade, we assembled all the window into a glass plane. We assembled a masonry into a vertical plane, so that it's exactly same proportion as surrounding buildings, but it appears to be very, very different. But it didn't require any variances and working together. So in a strange sense, it looks like a bit strange building, but also recessive idea of a black. And it looks gray in sunny days. When it rains, it has a different colorations. So it's, for the time being, it actually has a very harmonious relationship with the neighbors, precisely because of its mutable quality, that it's changing. So it's never been a very heavy neighbors. And in a way, geometrically, it's very different, but it's the same proportion. So it kind of makes it balance out, except even though it's actually very different appearances as you can go through. And this is looking through the historic building in Soho, and some of the built ideas, similar ideas continues into the detailing of a stair, and some of the light leaking through the stair. And also, I just have to mention, this project used to be a project of Della Scopidia Renfro. And they just did not go through with the initial project. The client came to us, and Liz Dilla was in school, Cooper Union with me, says I just have to ask their permission. I can't take the job away from them. And I called up Liz and Rick, and they said, oh, we are too busy with too many big projects, and you can have this one. So I said, okay. And it's actually around the corner from my office too. So it was very easy to go for site supervision and walking through. But what they left is this amazing glass blocks we found on the basement. They meant to use. So we used it to line the walls of courtyard. So this is tribute to Rick and Liz. It's like we used what we found, and then we acknowledged this used to be a project, but we completed it. But it looks like this at night. It's translucent glass blocks, and that's the kind of, this is actual photograph of what it looks like in it. So in terms of this lecture, this is very contextual. This is a neighborhood, and then it's very static building, but it works in terms of a function and program. And I would actually present next project is very, very different. And it really relates to what happens when we start to observe issues of a program. And the project is called a portable concert hall. And it started as seminars at the GSD. And students in that seminar are still part of us, which means I actually formed a nonprofit with 2 other partners, and one person, Hilda Ochoa Brillenberg, who founded Youth Orchestra of Americas, United States. She's from Venezuela, and some of you may know that in Venezuela, they offer music education free to any child, and through that, they created El Sistema, which gave education free to all the kids who are talented. And then it produced amazing musicians, including Gustav Dudamel at Los Angeles Philharmonic. Is one of the persons who came from that system, and he's also part of a Youth Orchestra of Americas. And then Jim Bildner, who is a senior fellow at Kennedy School of Government, who came up with the idea of a nonprofit that has a very different idea of not depending on the donations only, but in a way to actually produce its own income. So this is a test case project for different case for nonprofit, as well as ideas of making a portable concert hall. So it's been a very long time of a research. And we also got idea of acoustics, which is necessary for concert hall, regular tent sound escapes. And then also when it rains, it's too noisy. So it really doesn't work when it rains, when you need a tent, you can't hear the music. And also youth orchestras of Americas go to remote places all over the world, especially in South America. And then there are many villages. Most of the places don't have concert halls. And concert halls, by and large, are very expensive to operate. And there's hardly any concert hall actually is profitable, except one which is never designed for concert hall, but it's actually is one of the most profitable concert venue is Yoyogi Stadium by Kenzo Tange. That's actually one of the most popular rock and roll concert hall. So it's very ironic that that's actually plays that role, but and it's expensive to build and expensive to operate. And for orchestras, if they come up with one program, they can't repeat it more than 2-3 times, even with big cities. But if they can travel with a concert hall, they can go to many cities and they can actually repeat the repertoires. And another thing about this idea is that classical music, because it's very difficult to operate a concert hall, it's very expensive to attend concert, which means it becomes elitist, exclusive activities, which excludes amazing amount of populace, which conversely makes classical music obsolete if it's only available to very few people. And then with the youth orchestra program, they figured out there are so many youth who's actually talented and they could be trained, and then the music, classical music, can be accessible to more number of people less expensively and hopefully for free. So there's so many different missions that's associated with this project. And then with it was a collaboration with Philip Glass, an American composer. And this is Philip sitting there. And he actually said this is a concert he went in Athens, Greece, in which it started to rain. So audience came with umbrella and put it over musicians so they can continue the concert. So he says, anything, this concept of umbrellas that can create this portable concert hall. Also, his music, his early music came from Africa, and then he traveled to Africa and djembe drumming, and he also traveled to Silk Route. He says that I'm a nomad. So nomad musician needs a nomadic buildings. We can't just be sitting in Lincoln Center and Carnegie Hall. Some architects come up with a new typology? So that's the reason we came up with this idea of continuing research for this typology as we continue the conversations to go through. So the current scheme is this series of umbrellas. And then we have a collaborator in Japan named Taiyo Kogyo, which is a membrane company. And it's a privately owned family company. It's currently run by a very young CEO. He's about 35 years old. His father died recently and he took over. So it's the third generation. And they were known to do Expo 70, collaborated with Kenzo Tange to do some inflatable structure, which was really popular, made popular by Expo 70 then, but especially US Pavilions by Davis Brody. And they continue this membrane. And currently this family-owned company has a 75% share of membrane structures in the world, which means they do all the World Cup stadiums, all the membrane structures for Milan Design Fair, to a tent structure in Mecca, outside of a mosque. So it's kind of an amazing global company. So we are lucky to have a collaboration with them to come up with this. And also we have collaboration with Arab Acoustics, because they've been constantly making a digitized model of acoustic to test if this is going to work out. So the geometry of it is a series of umbrellas. And as an early image I showed you, we were inspired by English Gothic cathedrals in which very large structure, but then you can hear the choir quite into entire length of a nave very clearly without sound enhancement. So the particular shape of a Gothic structure, and then also in combination of umbrella structure was something we intuitively knew that it has acoustical properties that combined with membrane, which has some capacity to contain sound, and then certain membrane which can reflect the sound back into the audience. We knew that's actually the one to do it so that one can hear the music well, and then without needing a microphone speaker sound enhancement system, in a sense, delivering live sound to the audience. And for this one, it has module about 35 feet by diameter. And we come up with different modules of a 300 audience, 600 up to 900. And also the requirement is that it can be scaffolding, and then each member can be carried by 2 people. And so that it could be constructed manually. But of course, I think in places, if we are actually proposing the center of Tokyo, labor is expensive. So the other machinery will be more efficient. But we essentially came up with this idea of a series of umbrellas, which become dependent with each other structurally, in which case your concept from a structural engineer for Switzerland came up with interdependent structure, so that you don't build just one umbrella after another, one member takes over the other, which we like this idea of building up a community. Everybody's interdependent with each other. So these are the capacity for these 3 ideas. And this is a section through it. And I think one of the important idea is that we do have a central section which is clear of columns, so that a conductor can see the orchestra and the audience can see the orchestra throughout. And this particular shape came up with a glass idea that Ninth Symphony of Beethoven should be the one biggest requirements for the full orchestra plus full chorus behind, and we should secure minimally that amount of space around the stages, and then audience will actually work around it. And so this shows a section of 3 different sizes, and as you can see, where the piano is placed is typically where there's no columns in here. So that's actually the layout. And I have to say, this is pre-COVID, and we were able to assemble this to many people. And this was a structure around that we were working on. And then in this case, we had different layouts for chamber music or full orchestra. And also idea that this umbrella can collect water in rain season in the communities, so that they can actually, if they actually choose to keep it, this become a rain collector. So it's actually a very big idea for us. And also, as I mentioned before, what happens when there's rain, the tent membrane structure can act like a drum, so that you actually can hear the music. And with Arab acoustics, we came up with a rain screen mesh, which was invented for Beijing Olympics swimming pool. And some of you might have experienced when they didn't have this mesh, you can't hear anything inside of that swimming stadium. Once they put the screen mesh on, it became very silent. It's a very strange idea, but we actually tried it. We came up with a certain amount of mesh. It's not too close, but it's open enough so that raindrops can hit and bounces off. If it's too tight, it bounces, it has the same effect of a drumming effect. If it's too open, the whole thing comes right into the umbrella fabric, again, causes the same thing. So, and then we tested this out, and it's strange also, the screen mesh is slightly, it's not very tight again. It's actually just, it has this yielding effect that it's not completely tight, and actually has this bouncing effect to work with raindrops coming in. And we had to do this testing of it too. Also, we talked about having lightweight photovoltaic panels attached or embedded into a membrane structure. It's like a patches of a photovoltaic panels, because these will travel to places without electricity, so that if this tent has capacity to produce its own electricity, it's actually much more advisable. So we have this much more high-tech ideas. This is photovoltaic panel concept here. And this is a kind of rendering of what that would look like. And this will be interior view. And there's me and Philip Glass going over the models. And he just saying like this idea of a looking a bit like cathedral, but in a sense, this inside structure should be inspirational to musicians because they're playing in this amazing space. And he gave us all the criteria for programming of this. And we did this full-size mock-up in which we tested capacity for a collection of rain, and also the acoustics of putting a mesh and then hose. We borrowed a fire engine close by and came in enormous amount of, and then also we did acoustic testing, which turns out to be better than a tanglewood with microphone speakers. So it's just tested very well. This is a full-size mock-up we have come up with. But currently, this is doable, and it's actually for a structure like this, $1 million probably not that expensive, but we actually wanted to improve on this. And we are currently working to use air beams, which is a technology developed for Expo 70, but no one really touched it. So we are currently working with Taiyo Kogyo to develop a new model, which is completely made by membrane and air, and avoiding metal altogether for economy, and also ease of transport and assembly and disassembly. And then also a more ecological idea of using this to be able to use and reuse. So these are some of the models that we are working on. And also during this COVID, we were asked to look at possibility for a module to be used for field deployment of hospitals or patient places. In Japan, as you can imagine, houses are very small, and if one person becomes COVID, they're not ready to go to hospital, but actually hospital has capacity problems too. So the interim space where they may be housed for some time to recover, to get better, but isolated. Like it's not completely isolation. So there was a need for this kind of spaces. So we're asked to develop this, and especially using air beam. And so we have done these proposals for it. And also we were asked to do layouts for education, socially distanced, that it will be perfect for kids. It's outdoors, but it's covered. So 3-season classrooms. In Japan, it doesn't get that cold, and it's possible for kids to be there. So we had to do layouts of different types of field deployment and social distances. But with the social distances, with this concert, we could house 100 people instead of 300. And performance was saying that it's actually maybe this is what we need. We could do 3 performances, but at the moment they are all craving for interaction with the audience. And for them, doing performance over Zoom is like doing a rehearsal when they are performing in front of an empty stage. So I think this is some development within probably this year. There's a realistic idea of making into reality. It took us a long time to do research, identify everything, technological development. But again, this came from a really simple observation of why is music not accessible to wider audience, and why is concert hall not economically doing well, and is there any other alternative typology? So this came from very simple observation and conversation with musicians to going forward. Another small, another, it's not so small, but it's a project coming from observation is Baffled Botanical Gardens, in which it was Olmsted designed the botanical gardens in 1894, and this was Lord and Barnum building built in 1899. And we were asked to develop a new program to make it workable, to make an addition to it. So this is the way it looks like. It's actually very beautiful, Lord and Barnum early one, and Lord and Barnum originated in Buffalo, New York. So this is something very important. And then we came up with a plan which opens up the back of Botanical Gardens to Olmsted Park, and also to improve circulations and new use of it, more educational ones. And this is actually the idea we came up as a new botanical garden and using ETFE as a membrane instead of glass. So it's actually more ecological, meaning you can actually inflate it with a very little bit of electricity, and then it can deflate it as it needs, and one can actually have a different shading gradients for appropriate plant growth, and it's much lighter than glass and easy to maintain. So there's a lot of advantage to do this new material, and then to going into a future, having this different geometry, which may benefit from a visual geometry to have much more comprehensive way of programming and working together. And this organic shape works better with shapes of a park. There's a simple idea of unzipping a typical greenhouse and then parametrically developing it. So each section of what we propose is actually a section like a typical greenhouse, but it actually develops into a different shape and sizes. This is a partial model of it. And this is photograph within the model. And this is a rendering. This is a complete rendering. And we finished schematic design. We're just about to launch into design development. It's a long time project, but in a way, idea of how to enhance the quality of existing historic structures and observing it as something historical artifact, but then making a possibility for future development, and then making into not only a left out artifact, but launchpad for the future vision is important, and especially the role of botanical gardens as studies of ecology, which is important for kids and adults alike. So the botanical gardens used to be the display of a colonialist riches of plants, but now it's transforming into much more of an ecological center of education. So it's changing a role rapidly as we speak also. So related to that, you actually started to see that I've been using these curvilinear ideas throughout and working with engineers in ETFE. And I show this is a subway canopy. It's probably the smallest structure in Hudson Yards, has developed huge amount of development. But this is subway line which comes in, and it has enormous amount of people coming in through. This is only public transport area, but people leave and arrive. And we collaborated with Schreich Bergman's office, structural engineers based in Stuttgart, but they also have office in New York. And in this, we work with a hybrid. It's actually, it looks like a turtle shell. It's a hybrid dome and then hybrid tunnel. And we came up with a shape because if some of you have been to Hudson Yards, it's incredibly windy, the wind coming straight up from Hudson. And we shaped it so that the wind comes or above it. But then it's multi-directional, so that one has an idea of identifying it and come from different parts of a city to be able to identify and enter into it. And we had to deal with MTA because their structure is very rectilinear. We had to say that it's going to be a wind tunnel if you build that. You just have to come up with a shape that works with the condition of a site. And again, idea of a wind is something we observed, just being on a site and trying to be standing up straight, and you're constantly getting blown up. And then as an architect, we have to do something about this. So that was an interesting generator of it. And with this particular ideas of techniques of building, this is a grid shell, which is particularly developed by Schreck Bergman's office. We've been in different discussions, and it's important to show because last two projects I'm showing today is a collaboration with this engineer for two projects in Africa. So we are going now to Africa in a very remote region. Dakar, as you see, is the capital of Senegal. And then this is sub-Saharan Africa, which is like all the grass and very dry. It has rain season, usually starts May into mid-September, and then dry season. So one actually goes around in cycles. And the site is red circle near Tambacounda. It's about 7 hours drive from Dakar, a very remote area. And we were asked to develop a cultural center by Joseph and Annie Albert's Foundation. Going back to the origin of this project, which is that I actually did an exhibition design of Annie and Joseph Albert's at Cooper Hewitt, and that's how I got to know Joseph and Annie Albert's Foundation and realized that they are doing work in Senegal. I was very curious about it, and they asked me if one would do a studio with Harvard GSD students to see the possibility of a future. I said, oh, that's very interesting, but I've never been to Africa. And then, but it's a very poor area. How would be productive to take students there when the money the students can use to travel can be used to given to community directly? And there's a Nicolas Christophe is a Harvard graduate. And one of the events I asked Nicolas Christophe, I have this dilemma in which this foundation wants me to take Harvard students to these communities. But with the money Harvard students would use to travel, the community can get food and clothing. But he said, it's actually, you should do it because the future is the students and what they gain out of it and what they offer and what they become in future is more than the food they get for one day. So with that, I trusted him. And of course, he has this program of he takes students to some of his journeys to expose them to realities of the world. And he calls it taking them out of their comfort zone. So that was my mission. And with that project, I think I took GSD students twice. Everybody had to get a lot of shots. And then the malaria pills, and you can't drink water, and you can't eat anything raw, and all that situations. But we did the research. So I had this idea by the time after the studio, they asked me to design the cultural center. I had these ideas, and also Jordan McTavish, who was one of my students in one of the seminars, was in my office. So we took this project down as pro bono, knowing that it's a very remote community, one of the poorest part of Senegal. And then Albert's Foundation has been working for years. They are nearly 25 years. Actually, Financial Times did an amazing article about the activities in this past Sunday's special edition. It's called How to Spend It. That's actually, it's like a, but in a sense that how Albert's Foundation spends it for this community for 25 years, because it's been a community with the highest rate of maternal mortality and infant mortality. And originally they worked with French doctors, sent doctors in, and over the more than 2 decades, they built clinics, they built maternity center, they have built kindergartens, they built farming school. Then, so they said Joseph and Annie Arbor's art organization, it makes so much sense to do a cultural center. So this is the site, and that's actually site is within the compound of a clinic. So we work with the doctors in the clinic, and it kind of shows it's about 700 to 800 people, villagers. And this is clinic is important center. And as you can imagine, Senegal is 90% Muslim and only 10% other Christian, Jews, and non-associated religious practice. So it's really Muslim countries, and they don't trust Western medicine. So it took them more than 2 decades for the villagers to trust it and became a part of it, and then nearly eradicated maternal mortality and infant mortality in this area by these efforts. I just say that because it's a very important part of our mission in terms of public health, aligning with the cultural institution. And the site is like this, it's a village and vibrant community, incredibly artistic in terms of textile designs and costumes, but a very, very arid area, a very dry area, flat area. And to your left is Dr. Mageba, who runs a clinic. And he was a youth when from this village, worked in a clinic when he was young, and he went to St. Louis, is another big city like Dakar, to study medicine, but he came back to head this clinic, which is built by Alba's Foundation. And his logic is that he realized that he has to stabilize these rural areas where they have highest rate of migration, and then there's no jobs and there's no hope. And then we have to stabilize it and keep young people there. And so this clinic is completely run by local people, and they keep sending young people to medical schools in the cities, and they keep coming back to make it robust community. And this is what the clinic looks like. And Muslim communities, because it's a big family. So if you have somebody becomes sick, a family comes in, family can be 30 to 40 people, and they sit around in it. And so they wanted to integrate the cultural center as a part of a clinic. So when a family comes and they go to the cultural center, and if there's some illness which might have a stigma attached to it, there's another reason to be here. So in a sense, camouflage these kind of conditions. And then, so this idea is multi-use. It has workshops, exhibition, artist residence, and marketplace, and originally made to have 2 artist residents and then director's office. And they have been continuing, I think now it's a 5th year, to have international artists come in and also local artists come in, African artists, European artists, filmmakers, many different people, and they actually come and interact with communities. Also, important aspect of this particular area is that it's the area of about 12 different tribes speaking different languages, and then they actually exist peacefully. And one of a big gathering is they perform together, they bring their own instrument, perform, exchange music and performance together. And the doctors themselves even make a skit for them, because you can't send out pamphlets, they can't read, they don't share one single common language except French, which is colonialist language that they share, but in a local language, they don't share it. But with a performance, they have a skits in which they generate in cultural center to go to different villages so that they can see a funny skits, so they know how to put up mosquito nets. Like now they're probably doing all the skits to encouraging vaccines for COVID, and also Ebola, they did skits so that they actually refrain from a habit of washing dead bodies, which is very important. So imams participated into them, and that's actually where you can contract Ebola. So we have to do different rituals for different purposes. So this kind of adjustment is made. So these are kind of activities that's taking place here. And at the same time, there's a drying of wells because of aquifers drying, climate change. And this was actually abandoned aquifer, but now if one village location drills a well, it dries up in the next well. So, and then they had made this amazing analysis of how much water they use, villagers, animals, how many. And with this, we actually came up with the idea of what if we were able to collect rain during the rain season. And with all this data, we realized that if everyone were able to, every building can collect water during rain season, they can totally survive through the dry season. And we said that this particular roof should be able to collect about 30% of villagers' use to optimize the slope. And it has two cisterns that helps to collect it. And again, we work with Schreiss Bergman to come up with this optimum roof shape and working through this. So these are the ideas. And also it was built with mud bricks made locally, just their own mud. Luckily, they have a high alkaline earth, reddish one. They will build it during the dry season and dry it by sun, and it's structurally sound, but also to provide openings for ventilation, and a local bamboo in the thatch, grass thatch structure. And one of the reasons is because we want to use local material, but also local labor. And these villages, they cannot import materials. It's too far and also too expensive. And also idea is to give jobs to the villagers to provide income, but also for them to be part of this project, and they are able to keep maintaining it. For example, the thatch roof can be blown off by wind, but they can cut the grass and the villager come and repair it, and they get paid for this. This is actually a very interesting idea. So this is about 2 years ago what it looks like. It was never green like this, but because of a collection of water, they started to have agricultural gardens, which was never conceived before. We did not know how they would use the water for, but they realized that it's counterintuitive, but in a very dry area, one can control use of water and one can manage agricultural production better, perhaps some places with a huge amount of abundant rain all the time, because they can actually control how to work through and control the type of plants. And this is a typical hut they live in, and this is a kind of technique we work together to come up with the bamboo structure area. So the challenge for us as architects in Schreiss Bergman is to make use techniques used at domestic scale, but enlarge it to a public building scale. And luckily, Schreiss Bergman has been used to working in Southeast Asia with bamboo structures, so they are very knowledgeable about how to work it through. So what we did is we digitized the entire thing, and we actually did incredible analysis and put it back together in terms of how to be built, hand built in it. And these are the techniques that relate together. And the idea is to have a compression ring in a skewed condition, and then the ring is actually sitting on top of it, and then it's actually radiates out. So in a way, we had to design it so they can be built in a sequence because they don't follow blueprints. And it was a very good lesson for us to be able to design something which can be built in sequence. So they built the perimeter beam in a central compression ring, and then they started to project bamboo structure along it to work it through. And some of the area where it's more stressed has a double structure in green, as you can see it, but it's not so foreign, it's actually existing technique. And this is a kind of diagram we provided to see this is first lay it out and then going together. And then that's how one can actually put things together. And that's actually some of the construction. In construction, you can actually see this, some of the steel was added to strengthen it, but those are kind of small angles. And we were able to purchase those small steels, and also Portland cement may be the only thing we were able to get. And the kids are supposed to be in school, but they all wanted to come and help build this, help it out. Dutch people are very skilled, and they were able to work it through and strong enough. And also they were looking at Annie Albert's examples, and some of the materials and photographs of Annie and Joseph were abandoned there because it's run by the foundation. They have a small library on the site. And then with them, they actually made it a little bit thicker than traditional thatch roof, which gave them more insulation capacity. And what's interesting about this thatch roof is that it's, grass gives direction. So it kind of directs the rain into this canal system right below very efficiently. And I think this is something we learned about thatch roof from thread. And the last project I showed in a school is that thatch is a series of grass and it's densely packed together, but it's still porous. So that when hot air comes in, it can gradually go out. It naturally creates a stack effect if we orientate the building properly. And that's actually what we did. That two circles are oriented to the direction of wind so that there's a breeze inside there constantly, which is a big deal for a place where it can be 115 degrees constantly in a still air. So this building also manages to create some issues of comfort. This is how they make the mud blocks. And these are examples when Joseph Albers worked with brick buildings, and especially if you in New Haven, Connecticut, there's a lot of buildings in Yale campus, and also in Harvard Law School. This is actually an example of Albers that has done it, and combined with more of a local tradition such as this. And this is a local tradition in which it prevents storm to come in, to prevent sandstorm, but you can still have ventilation. So this is the double purpose of it. And under construction, and such, and we had a white plaster on it to get the heat off it. So what you see in the grass is what you use, and they constantly grow it to make sure they can repair it when there's something comes in. And this is what kind of looks like from inside. Also, they were inspired by this Joseph Albers, one of the earliest work called glass painting. And Joseph Albers was very poor when he was a Bauhaus student. And in fact, these glass pieces, he got it from the garbage can in Bauhaus and put them together. So inspired with this, there were broken tiles. We were able to get it from Dakar, which is discarded building material. And looking at Albers' work, the villagers started to do mosaic. And then there is this mosaic technique already, because they are also using this discarded tiles to do it, and working together with Albers' inspiration, this local ideas and local technique, and then enhanced idea, or start looking at Albers' ideas, and also to have this male colorations. It became a very interesting idea. Also looking at Joseph Albers' design, a lot of furniture. This was designed for Harvard dormitories, looking at them, and they built their own furniture a la Albers' ideas, same as the stools. And also these are some of the mock-ups of a brick work of Albers, but appropriated for doors. They kind of did them on their own. It's DIY, but I think these are incredibly beautiful, and especially with that white floor, system. So the center has many different uses. The kids come there, hang out at night, and we do have generators at night. So that's actually where they come to do homework. The ladies come in, and it has many different type of spaces, which allows diverse communities to occupy all at once. And I think that's actually was the idea behind it. And this was the opening. About 2,000 people came there, and it's maintained by the rotating villages, maintain it well. And but now 4 or 5 years later, this is how the planting became a big program for them, and then it becomes an income source for women here, and they will grow a high yield, meaning like it's actually very good plants, vegetables to sell, because it sells in high prices, like okra, eggplants, and they start to produce honey and fonio, which is another kind of grain, very fine grain that they are selling as a product right now. And so that's actually the aspects of it going throughout. And these are some of the scenes of communities, and continues to be very vibrant communities, and continues to be more and more green. So this is a view of it at night. And with it, we've been doing a lot of research of that structure, because we are very much interested in the possibility of geometry. And the last project I show you shortly is this fast school on the top. But for Chicago Architectural Biennial, we were invited to show the research part of it, to have a modular idea of a different type of geometry. With this particular technology, one can actually come, and these are some half-size models that we were able to create. And the last project I show is Fast School, also by Albert's Foundation. And then this school is elementary school from age 6 to 10. And this is much further on the other side of Gambia River, in one of the driest area in Senegal, in sub-Saharan Africa, and probably most conservative Muslim areas, in where this is the first elementary school to teach any secular education. There has been religious schools. So in a way, the kids are not able to read or write or add numbers. And it took about 3-4 years of negotiation with Nicholas Fock-Feber, who is the head of Albert's Foundation, with imams. But imams is the one who wanted Albert's Foundation to build a school, because they saw possibility of a gathering at thread. But the curriculum has to be inclusive of secular education, which will be a future for the kids. They can't just be ignorant throughout their lives. I mean, in a way, the religious education is very important, but of practical matters. And this idea, a combination of ignorance and poverty, can be lethal. And also the boys and girls study together. That was very, very important ideas. And they have eventually come to terms, because at first they thought this was against the elders' teaching to teach kids practical matters, including cooking or wood building. And but they came to understanding that actually is an extension of elders' wishes to include contemporary knowledge, so that they can actually survive and protect themselves for future. And as you can imagine, these are the kind of communities where that kids become targets for recruitment for terrorists, because they don't know any better. They can't make judgments. They can't read what they're signing on to. So they came to realize it. And then this became very quickly a reality in terms of schools of 4 classrooms and a teacher's residence and bathrooms. And an idea is similar to thread, but it's a circular school. And we call this, they speak French, so the l'école maison, in which schoolhouse in America, there's one room schoolhouse which Joseph Albers taught. And idea is that they come from different communities, but it's a house. And it's not like regular schools they go to. They're normal schools made out of corrugated metal roof, which makes huge noise during the rain season. And also the kids get cooked in the hot weather, as you can imagine, and then concrete blocks. So it looks like a prison and none of the kids want to go there. And then if they have to study outside of the schoolhouse because it's too hot and stifling inside. So environment was a problem also. So what we learned in thread, and also it's the same group of people, luckily there's another outpost of a clinic run by Dr. Maggie Ba, which is right next to the school. And the school also wanted to combine and include public health education for kids, which is very, very important. So there are the bearing walls of different sections. And so that the circular elements are slightly skewed, but they're also oriented toward west wind direction. And then so that there's a breeze is throughout, and the peak of a roof is helping to stack effect, and then to keep the classroom cooler than outside temperature. And in fact, I think it was about 10 to 15 degrees cooler, which attracts kids to be there, which is a big deal because if the kids want to be in a cool classroom and feel comfortable studying there, that's a huge improvement. And then about 200 kids signed up. And even during the construction, it became a popular place of gathering, and that's how it looks like. It has this little ancient look. It does have a prototype of ancient housing typology, but it has different geometry. This is my team. I'm very proud of my team I'm working with. And some of them are Christians, some are Muslims, and we work together. Some of them are from Thread. And then this is a clinic next to it, and this was opening day. And then girls and boys, they come together. It has very high ceiling, and it's similar to Thread. It has structures, and that's the classroom. We designed the furniture to school teachers. And this is a courtyard, and one of the aspects of this round thing is that as sun moves, it creates different shadows so that kids can be in the shadow, and then but it brings in enough light together in these inside outside spaces as we go through this. And these are photographs by Yuban Ban a couple of years ago, and this is a view, his view. And then this is the entry. This is also just showing these are the kids, and then in a way, this now becomes more like icons. They kind of know this as a school, and they call it L'École Maison, and schoolhouse. And then also, I didn't show it, but women have cultivated plants like in Thread, and they have now double the capacity and so forth. But to close this lecture, I just want to make a statement, and we characterize with inclusive term observation. We have come to realize that the unique way in which architects conceive of and identify problems is more speculative than generic. The architect's method is often comprehensive and open-ended, allowing multiple strands or narratives to coalesce. The earliest stages of programming a project are preoccupied with framing and reframing a set of criteria, observing the field of possibilities. Observation is a form of rumination, a quiet and precise practice that sets up a framework for propositions for the future. So thank you very much.